Welcome to the Essentials playlist of the Genesis YouTube channel. In this playlist, we'll be taking up problems which I consider are very essential for every student to solve. With this aim in mind, let us consider the first problem. In this question, a uniform sphere of mass m kept on one end of a plank of mass capital M is shown. The coefficient of friction between the sphere and the plank is mu. Neglect the friction between the plank and the sphere. The sphere is given a horizontal velocity u as shown. When will the slipping between the sphere and plank cease? That's the question. Now we will draw the free body diagram of the sphere and the plank. I will draw first all the forces other than friction force, then infer the direction of slipping of the bottommost point of the sphere on the plank, and then draw the friction. So what are the forces acting? Small mg of the sphere, the normal force between the sphere and the plank, the capital Mg of the plank, the normal force from the ground on the plank. Now you can see that every point of the sphere, since it has been given no rotation, is going to have a speed u, and therefore the bottommost point of the sphere is going to slip rightwards relative to the plank. So the friction acting on the sphere is going to be mu n in the leftward direction, and its reaction will be rightward on the plank. The friction is kinetic because slipping is occurring. Due to this leftward friction, there will be a leftward acceleration small a and an angular acceleration alpha on the sphere and an acceleration capital A of the plank. Now we write the force equations. For the vertical equilibrium of sphere, we have n is equal to small mg. In the horizontal direction, we can write mu n is equal to small ma. And the torque equation for the sphere will become mu nr is equal to 2 by 5 mr square alpha. For the plank in the vertical direction, n naught will be equal to n plus capital Mg. And we will have mu n is equal to capital M into capital A in the horizontal direction. Now from these we will immediately get small a is equal to mu g, alpha is equal to 5 mu g by 2, and capital A is equal to mu small mg by capital M. Now let us see what has happened to the velocities of the sphere and the plank after some time. Now there is a retardation on the sphere, so its velocity would have reduced and the angular velocity would have been imparted by the torque of the friction. So let the velocity of the center of the sphere be small v and angular velocity be omega. Let the bottommost point of the sphere be P and the point of the plank which is in contact with that be Q. Let the velocity of Q be capital V. Now at point P there are two velocities, V and omega r. Now understand that V is continuously decreasing, omega r is continuously increasing. The bottommost point P has a velocity in the forward direction, and for slipping to cease, these 2 points P and Q should have the same velocity. So slipping will cease when Vp equal to Vq. Now Vp is V minus omega r and Vq is capital V. Now this V is u minus at because it's retarded, and omega is alpha into t because there was no initial angular velocity, and capital V is capital A into t. From this we immediately get small t is equal to u by small a plus capital A plus alpha r. Now remember we had these three relations. Now these three relations now we can substitute back into small a, capital A and alpha r, and this gives us u divided by mu g plus capital A is mu small mg by capital M plus alpha r will be 5 mu g by 2. And now if you simplify this, the value of t comes out as 2 capital M U divided by mu g times 2 small m plus 7 capital M. Let us call it T0, and this is the time at which slipping ceases, and this finishes our answer. Now, as an exercise for you, I would leave it up to you to find the velocities of the sphere, the linear velocity and the angular velocity of the sphere, as well as the velocity of the plank at the moment T0. Understand that after this, these velocities are not going to change, and immediately after T0, the friction force will vanish because slipping has ceased. Keep watching this playlist for standard problems that everyone should know the correct solution of. Also keep checking the JEE Advanced 2020 Physics Solution playlist as well as the Problem Corner playlist. So till the next time, stay safe and stay healthy you all.